So for my Pythagorean equation, it shows 5 squared plus 12 squared equals 13 squared. To find the angle we will rotate the conic by, we need to do the inverse tangent of b over a, which is tangent 12 over 5, which equals 67.380. The d value I chose was 10, and the e value I chose was 5. And the problem tells us the foci is at the origin, and then the vertex is at 15, these points added together. So the c value of the hyperbola is 10, because that's the foci distance from the center, because the center is, we also were told the center was at the d0. The a value is 5, because the difference between 15 and 5 is 10. That's the difference between the vertex and the center. That's the a value. So to find the b value, we do 10 squared equals 10 squared equals 25 plus b squared, because we square 5, so like this, so it'd be 5 squared plus b squared equals 10 squared. And that equals b squared to be 75. So the equation of this hyperbola will be x minus 10 over 5 squared minus y squared over 75 equals 1. To put this in polar form, or this equation right here, we need to find the e value, or the eccentricity, and the k value. So the eccentricity is c over a, which would be 10 over 5, which equals 2. And then, the k value is the sum of the point to the directrix distance, or the point is the vertex. That's the point we're using. PD is the vertex to directrix, and the vertex to foci right here. And then the point over focus, point focus over point to the directrix is also equals to c over a, as you can see right here. They both equal the eccentricity. So we know 3 out of the 4 variables. We know 10 over 5, and in 5, because that's the distance from the vertex to the focus, we can solve for PD, which equals 2.5. So we can add k is the addition of PD and PF, so k equals 7.5. So we can plug our values into the polar form right here, and that simplifies to 15 over 1 plus 2 cosine theta. As you can see right here, I have this angle right here. Well, to rotate the conic, we have to put this angle in this equation. We do theta minus that angle. So we are left with this equation, and that's rotated 67.380 degrees.